Hello and welcome everyone to my channel Code with Ease. Today we are going to discuss another linked list problem as part of the linked list series. This is finding the middle element in a linked list. So we are given a linked list of n nodes and we have to find the middle of the linked list. Example, if 1, 2, 3, 4, 5, these are the nodes, the middle is 3. If there are two middle nodes, which will happen in case of n even number of nodes, then we have to print the second middle element, like we can see in this example. The second middle element is 4. Okay, and what we have to do is we are given a head reference to this. We have to return the data at the middle node, and the expected time complexity is order of n and space is constant. So this is the question that we have to solve. So let's move to the whiteboard and understand how can we solve this. So we'll just have a few nodes reference. So we'll do it for two types. One, we will do it for odd number of nodes, and then we'll also do it for even number of nodes. So in this, what is the expected answer? For this is 3. For this, the answer should be 4. Okay. So this is the middle element, and in this case, this is the middle element. This is what we have to find. What will be the first thought process that will come to our mind? The brute force way of doing this. If it is a odd number of, if the length is, the number of nodes are odd number, we know that the middle element will be just the half of that. Okay. If it is the even number, instead of this, we have to give the second middle. Okay. So the thought process, the initial thought process that would come to us would be to do one traversal of the length to ascertain, to understand whether the length is even or length is odd. If we know that it is odd, then we can just, if the length is 5, then we can do the calculation to print the middle element of that. Because once we know the length, it is easier to navigate to the middle. Similarly, the case would be for this second linked list also, where the length is even, and if we understand that it is 6, so 6 divided by 2 will be the third node. Okay, if we start from 0 index, 0, 1, 2, 3, third node. Okay, or if it is starting from first index, it can be third node plus 1, like that. So these are the things that will come to our mind. But the problem again will be caused by the time complexity that we are given. It is given order of n, which means we have to do it in linear time complexity, or in some questions you'll also see that it has to be done, the finding the middle of the linked list has to be done in a single traversal only. So when that happens, there is in no way we can do one traversal and then do another traversal. It is not advised to do that. The optimal way we have to think of. So we can think of some optimal way of solving this. Usually in linked list question, whenever something has to be done in a single traversal only, we use the concept of fast and slow pointers, or the Floyd detection algorithm. Floyd cycle detection algorithm uses these pointers, Floyd cycle detection algorithm. Okay. So this is the approach that we have to use. Fast pointer, what it does, it moves 2 steps ahead, and slow pointer does normally, it just moves 1 step ahead. Okay. So in this, what we have to do is, we will start from here. Let's say we'll have the fast pointer over here and also the slow pointer over here. Fast will move 2 steps ahead, so fast will be here and slow will be here. Fast will again move 2 steps ahead from here, it will move here, and slow will be here. Now fast, if we see, there is a, we can put a condition that if fast dot next is null, which is true, so now it will break the loop. So wherever my slow is at, that will be my middle element. Okay, now let's see if this holds true for the second linked list also. So we'll have fast here and slow here. Slow will move here, fast will move here. Slow will move to 3 and fast will move here. Now slow will move to 4 and fast will make 2 jumps. So fast will reach here means it will reach the null. Now we know that whenever fast reaches null, the condition will break, so it will come out. Now my slow, wherever the slow pointer is, that will be my required answer. Slow is already at 4 and 4 is the required answer. So this approach works in both the cases. So this is going to be the algorithm for us. We'll use fast and slow pointers. Wherever slow will be finally at, that is going to be the required node for us. Okay, so now let's see how do we make the code changes for this. So now we are going to do the code changes. So first we'll define the slow and the fast pointers. So that will be anyway pointing to the head. This is the slow pointer and this is the fast pointer. Okay. Then we will have a while loop, and in that we will check if fast is, if it is not null, and fast dot next is also not null. So if this is the thing, then what we have to do is we have to just move the pointers ahead. So slow will be equal to slow dot next, and fast will be equal to fast dot next dot next. This will keep on happening. Finally, when the while loop breaks, we will just return slow dot data. Why data? Because we have been told that we have to return the data at the middle. So you just return the slow dot data. So that's it. That's a simple code change. We'll compile this. Submit this. So that is about this question, finding middle element in a linked list. Do let me know in the comments below if you have any doubts or any suggestions or any questions. And please don't forget to subscribe to my channel so that it helps other people also. Thank you so much for watching the video.